Hi everyone! Welcome to the Analyzing Census Data in SAS Studio tutorial series. In the last video, I created a listing report that displayed the top 5 states by median household income within each geographical region. In this video, I'd like to further analyze median household income values using some of the statistical tasks available in SAS Studio. First, I'll show you how to use the distribution analysis task to examine the distribution of median household income values in each region. To determine if there is a significant relationship between median household income values and region, we'll use the One-Way ANOVA task. Finally, you'll see the correlation analysis task to examine the relationship between median household income values and other statistics like mean hours worked per week and median monthly housing costs. For this tutorial, I will assume some knowledge of statistical tests and concepts. The focus will be more on how you can perform these statistical tests in SAS Studio and how to interpret the results. If you'd like to learn more about the concepts mentioned in this tutorial, you can take our free e-learning for the Introductory Statistics 1 Introduction to ANOVA, Regression, and Logistic Regression course. If you want to follow along with me, make sure you watch the introduction video to set up your environment and tutorial data. As always, you can find the link to it below or on the main tutorial page. Let's jump right in. Let's start by taking a look at the data that we'll be using. In the Census Data Analysis folder, I'm going to double-click on the state_info_combined SAS table. Along with some geography information, in this table, for each state, we have information about the median household income value, the mean hours worked per week, the total population, the median age, the median duration of their current marriage, as well as the median monthly housing costs. Now, all of these estimates can be found on data.census.gov. In the table, you'll see the one-year estimates for 2018 for all states. In addition, the geography information can be found in a geography lookup table that the Census Bureau makes available in an Excel file. I've downloaded this Excel file just to quickly show you what it looks like, but this file explains which region and division each state belongs to. If you'd like to learn more about census regions and divisions, the Census Bureau does make a PDF available explaining those. You can find the links to all of the sites that I have mentioned in the tutorial notes, which can be found in the description below or on the main tutorial page. To combine the estimates as well as the geography information into a single table, you can follow a process that's similar to what's outlined in the previous video on preparing census data. However, this was already done for you and again, all contained in the state_info_combined table. Using this table, I'd first like to examine the distribution of median household income values. To do this, I'll use the distribution analysis task. So in the navigation pane, I'll expand the Tasks and Utilities section, expand Tasks, and from the Statistics category, I will double-click on Distribution Analysis. Keep in mind that all of the tasks that we mentioned in this video do require the SAS Stat product to be licensed. If you are using SAS Studio through SAS On Demand for Academics, then SAS Stat is included. I'll start by clicking on Maximize View to go ahead and hide the navigation pane. First, to select our input table on the Data tab, I'll click on Select a Table. And from the census library, I'll select the state_info_combined table and click OK. Now the analysis variables role specifies the columns whose distribution we want to analyze. Since we want to analyze the distribution of median household income values, I'll click Add Columns, select the median income column, and click OK. Moving on to the Options tab, I would like a histogram, so I'm just going to quickly verify that that option is selected. And to add some density curves to our plot, I will select the Add Normal Curve and the Add Kernel Density Estimate checkboxes. I'll also select the Add Inset Statistics checkbox so I can have some statistics included in my histogram. So I'll expand the Inset Statistics subheading, and let's include the number of observations, which is selected by default, the mean, as well as the median. All right, let's see what we have. I'll give this a run. Taking a look at our histogram, the normal curve, which is in blue, outlines a normal distribution with the same mean and variance as our input data, state_info_combine. The kernel density curve, which is outlined in red, outlines a smooth approximation of the distribution of our observed data. You'll notice that these two curves appear to be fairly similar, although the data is slightly right skewed. Taking a look at our statistics, you'll notice that the mean, which is roughly $62,000, is about $2,000 higher than the median, which is just under $60,000. Now I'd like to know if the distribution is different across different geographical regions. So going back to our Options tab, I'm going to take advantage of the Classification Variables role. This can be used to create separate histograms for each classification level. Because I'm interested to see if the distribution is different in each region, I'll click Add Columns and assign region to this role. Let's give it a run and take a look at the updated results. You'll now notice that we have separate histograms for each region, and each region does have a unique distribution. You'll notice that the Midwest region has a right skewed distribution. The Northeast region seems to be closer to a uniform distribution, and the South and West regions have states with extreme values. So using the distribution analysis task, I can visually compare the distribution of these median household income values, and they do seem to be quite different among the different regions. But now I'd like to know if the relationship between median household income and region is significant. To investigate this relationship, I will use the One-Way ANOVA task. So first, let me go ahead and exit out of Maximize View. And in the Tasks and Utilities section, under Task, this time I'll expand the Linear Model section and double-click One-Way ANOVA. The One-Way ANOVA task will test and provide graphs for differences among the means of a single categorical variable, which in our case is our regions, on a single continuous dependent variable, which in our case are the median household income values. I'll click on Maximize View again to hide the navigation pane. And on the Data tab, you'll notice that census.stateinfo_combine is already listed as our input table. What happens is that the most recently used table in a task is listed as the input table by default, so we're good to go there. However, if you do need to select the table, you can always click on Select the Table to do that. Taking a look at our task roles, the dependent variable role specifies a continuous numeric column. So I'll go ahead and click on the Add a Column button, and I'll assign median income to this role. Next, the categorical variable role specifies a column with values that specify the levels of our groups. So I'll click Add a Column again here, and I'll assign region to this role. Moving on to our Options tab. By default, the One-Way ANOVA task performs Levene's test for homogeneity of variance to test that the variances within each region are equal. This is one of the assumptions that we do need to satisfy for One-Way ANOVA. I'll go ahead and clear a checkbox for Welch's variance weighted ANOVA. If the ANOVA assumption of equal error variances across all groups is not met, then you can select this checkbox. Moving on to the comparisons method, by default, the task will determine whether there are significant differences in the mean of the median income between each pair of regions with Tukey's adjustment, so I'll leave that as is. And moving on to plots, from the Display Plots drop-down list, I'll select Selected Plots. I'll go ahead and clear checkboxes for Means Plot and LS Mean Difference Plot, and select a checkbox for Diagnostics Plot. So we just want the checkboxes for Box Plot and Diagnostics Plot. All right, let's go ahead and give this a run. There are many parts to this output. I'm just going to point out a couple of portions. Taking a look at the overall analysis of variance table, you'll notice that the p-value is 0.0228, which is less than 0.05. What this means is that the test is significant. It suggests that there are at least two regions where the mean of the median household income values are significantly different. We'll see which regions are significantly different a little bit later on in the output. Moving on to the Fit Diagnostics panel. This contains a set of graphs that are commonly used to help validate the assumptions of ANOVA, and there are several assumptions that we do need to make sure are met. The first assumption is that the observations must be independent. We don't see appearance of repeated measures or clustering, and we can assume that the data was collected in a way to ensure independence of the observations. So the first assumption is met. The next assumption is that the errors are normally distributed. The first scatter plot on the second row of the Fit Diagnostics plot is a quantile-quantile or QQ plot. You'll notice that there is very little deviation from the reference line, so the residuals are normally distributed. We can also verify this using the first histogram on the third row of the Fit Diagnostics panel. This is our residual histogram, and this histogram displays a relatively normal distribution of the residual, so again satisfying our second assumption. The third and last assumption is that all groups have equal error variances. And this can be verified with Levene's test for homogeneity of variance, which is a little bit later on in the output. I'll scroll down to there. Notice that Levene's test returns a p-value of 0.1542, which is greater than 0.05. Therefore, the null hypothesis of equal variances fails to be rejected. So the assumption of equal error variances across all groups is met. So all of our assumptions for One-Way ANOVA are met. Scrolling back up to our box plots, you'll notice that the box plot indicates that the Northeast region has the highest average regional median household income, and the South region has the lowest. You can hover over any of the boxes or whiskers to display a tooltip that has some more descriptive statistics if you're interested in that. The big question, though, is which regions have statistically significant differences in the mean? So I'm going to scroll down to the least squares mean table. In the least squares mean table, first you'll notice that each region is assigned a number. So Midwest is 1, Northeast 2, South 3, and then West 4. Taking a look at the pairwise comparisons among all regions, notice the adjusted p-value of 0.0286 between regions 2 and 3, which correspond to the Northeast and South regions. With this value being less than 0.05, it indicates that the mean of the median household income values between those two regions are significantly different. The last thing that I'd like to do is determine whether there is any sort of relationship or correlation between median household income values and the other estimates and statistics that were included, like the mean hours worked per week or the median monthly housing costs. To do this, I'll use the correlation analysis task. So first, I'll exit out of Maximize View, bring back a navigation pane, and in the Tasks and Utilities section under Tasks, this is under the Statistics category, I'll double-click on Correlation Analysis. Clicking on Maximize View again to hide the navigation pane. Again, notice that our input table is already listed as census.stateinfo_combined, so that's good to go. Moving on to our task roles, the Analysis Variables role lists the columns for which to compute correlation coefficients. So I'll go ahead and click on Add Columns. And I want to assign everything aside from median income. A quick trick is to first select Mean Hours Worked, hold down the Shift key, and then select Median Monthly Housing Costs. This selects those two columns as well as all of the columns that are in between. And click OK. Next, the Correlate With role lists the columns with which the correlations of the analysis variables are to be computed. Because I want to determine the relationship between median household income values and the analysis variables, I'll click Add Columns and assign median income to this role. Moving on to the Options tab. Under the Plots heading, I'm going to use the Type of Plot drop-down list, and I'll select Individual Scatter Plots. These individual scatter plots will display the pairwise relationship between our analysis variables and median household income. Let's give this a run. Taking a look at our results, the Pearson correlation coefficients table displays the strength of a linear association between median household income and the potential predictor variables. The stronger the association between these two variables, the closer the Pearson correlation coefficient value will be to either -1 or 1, depending on whether that relationship is negative or positive, respectively. You'll notice that the Pearson correlation coefficient value between median household income values and median monthly housing costs is 0.93492. This indicates a strong positive linear relationship between those two variables as compared to the other pairs. In other words, the higher the median monthly housing costs, the higher the median income. We'll use the scatter plot to make sure and verify that that relationship is linear. So let's take a look at a couple of those scatter plots that were generated. These scatter plots will provide a visual of the relationship between median household income values and the analysis variables that we selected. First, taking a look at the scatter plot for median household income and mean hours worked per week, there doesn't seem to be any significant relationship between those two. Moving on to the scatter plot for median household income values and median duration of current marriage, there does seem to be a slight negative relationship between the two. This could indicate that the longer a couple has been married, the less the median household income value. However, there is an outlier here that may have had a strong influence on this relationship. If you hover over this outlier, we can learn a little bit more about it, and we see that this corresponds to observation number 34. Based on the tooltip right now, I don't know which state this is, but we could look at the input table and locate observation number 34 to figure out which state it is. However, we will enhance the results to also include the state information in the tooltip. Before we do that, let's look at one last scatter plot. And this is a scatter plot for median household income values and median monthly housing costs. The Pearson correlation coefficient value of 0.9349 indicated a strong positive relationship between these two variables, but now looking at the scatter plot, we can verify that the relationship is indeed linear. Let's now enhance our results by adding more information to the tooltips that appear in the scatter plot and also by sorting the Pearson correlation coefficients table. To do this, I need to modify the task-generated code. So on the Code tab, I'll click Edit to open up a modifiable copy of the code. First, on the proc course statement, right before the semicolon that ends the statement, I'm going to type a blank space, and this displays the autocomplete window with some valid options for the proc course statement. I'm going to type R to highlight the rank option, and in the syntax help window, you'll notice that this option displays the ordered correlation coefficients for each variable. I do want to include this option, so I'll go ahead and hit the Enter key to include the rank option. Next, in my proc course step, I can add in an ID statement that'll specify additional variables to include in the tooltip that appears in the scatter plot. So after the with statement and right before the run statement, I'm going to add in an ID statement and include the state and region columns, and then end that statement with a semicolon. Let's give it a run. Taking a look at our results, you'll now notice that the Pearson correlation coefficients table now displays the values in order from strongest to weakest in absolute value. And now let's take a look at our scatter plots. I'm going to scroll down to the scatter plot for median household income values and median duration of current marriage. Hovering over the outlier, we can now see that observation number 34 corresponds to District of Columbia. DC has a median household income value of roughly $85,000 with a median duration of current marriage at 10.7 years. Let's go ahead and save this program. Back on the Code tab, I'll click on the Save Program icon. And in the Census Data Analysis folder, I'll save this program as Median Income Correlation and click Save. I'll go ahead and close the Median Income Correlation tab and exit out of Maximize View. You can go ahead and close out of the correlation analysis, One-Way ANOVA, distribution analysis and state info _ combined tabs without saving the results. Now you know how to use several statistical tasks in SAS Studio to analyze census data. There are so many more statistical tasks available. If you'd like to learn about another one, try out the challenge practice in the tutorial notes. It'll walk you through the linear regression task to predict median household income values based on the mean hours worked per week. To learn about the other statistical tasks, take our free e-learning for the Introductory Statistics 1 Introduction to ANOVA, Regression, and Logistic Regression course. You can find the link below in the description or on the main tutorial page. Thanks for watching.